All right, let's look at bond enthalpies. We've kind of broached this subject a little bit while ago in another unit, but this is where we're going out and actually calculating it. So it's slightly different than enthalpy of formation. You'll be given values in a chart. Two ways to think about it. The sum of all of the bonds broken minus the sum of all of the bonds formed. This can always be kind of tricky because we often think of products minus reactants, and this one's backwards. So a lot of mistakes happen here, and so there's a couple ways you can really think about it. Now, in a pictorial sense, you have your reactant molecules. They take energy in to break all those bonds, just thinking of everything separate. Then when they come together, they release energy. If we had a delta H of reaction that dropped, this would be called exothermic. Other ways to think about it, or first way to think about it, you got your sheet given, some kind of representation of bond energies, like between carbon and carbon, carbon and hydrogen. This one's just given kind of old school style. And so we have to think of, you're often given just a chemical formula, and you need to understand the shapes and bonds that are present. So in this case, you have two hydrogen bonds, hydrogen to hydrogen bond, not hydrogen bonding like intermolecular forces. And you have an oxygen double bond. You need to be able to understand simple compounds. They're not going to do anything too crazy for you, but you do need to understand that. Also, something like water has two hydrogen oxygen, and there's two of these, so that's four. Again, adding everything up, being careful that you use your calculator correctly, minus the bonds formed, you can see that this is a release of energy, exothermic. Second way to think about it is that it takes a positive amount to break the bond, negative amount to free it. So you can think of it as adding the two together, but using one as a negative value and one as a positive value. The reason I don't like this too much is that none of these are going to come up as negative. You have to think about what that becomes. So you have to think of how will that be negative. But some people like thinking of it better that way. You get the same answer. It doesn't matter which way you do it as long as you show what you're doing. Either write the equation the first way or talking about something takes to break, free to form in the second way. So the idea is that you want to illustrate your reasoning and rationale in some way, whether it be this way or that way. I prefer this way myself, but again, to each their own. I think that's it. Oh, one last thing is just again showing you how, another example. This would be not likely to see on your test to where they're actually showing you every molecule separately, but it'd say something like N2 plus 3H2 yields 2NH3, right? Or CH4 plus 2O2 yields CO2 plus 2H2O. You need to know the bonding of simple molecules. Likewise, I add up everything on the reactant side minus the product side. Add up everything on the reactant side minus the product side. And again, these are not coefficients. These are the amount of bonds present. Okay? Keep those in mind as you use your values. Coming with any kind of questions? Take care.